Hey everyone, today we will solve the problem of deleting middle element from the stack. So given a stack, delete the middle element without using any additional data structure. So basically how it is defining middle element, something like this. Let's see from the example actually. So as in example 1, there are 5 elements in the stack and the middle element comes after 2 elements from the top of the stacks, right? So 40 and 50, these are top, and then 30 is your middle element which is removed here. So in case when size of stack is old, we can say that the middle element comes after n upon 2 elements from the top, where n is size of stack. N upon 2 elements after n upon 2 elements. This n upon 2 is actually a integer part. That is how C++ and Java division work, right? So when n equals 5, so this will give me 5 upon 2 will become 2. So in this case, when there are 5 elements, so these 2 elements are n upon 2 elements, and after that the middle element comes. Similarly, when n equals 7, then it will be 7 upon 2, which is 3, right? Now second case, that is when size of the stack is even. In this case, you can see like middle element can be 20 or 30. So in our problem they have selected 20, that is the one which is more left in this stack. So again it is the element which comes after n upon 2 elements from the top, right? So n equals 4 and it comes after 2 elements. So what I'm saying is n equals 4, so n upon 2 equals 2, and when n equals 6, then 6 upon 2 equals 3. We have to remove this element which comes after n upon 2 elements. So how do we solve this problem? So basically we want to create a function which removes n upon 2 elements from the top, then remove the middle element which will be on the top now, and then put the n upon 2 elements back to the stack. What I'm saying is, suppose these are our elements. We want to create some function which will actually keep these aside, like it will remove these elements, then delete this 2, and then put these 3 and 4 back to the stack. Okay, now our function cannot store 2 elements or 3 elements because that will require some array or some stack or some other data structure to store, right? So how do we solve this? Let's see what we want from that function. We want the function, so actually we want the function something like remove after k of given the stack and given a k element, k number, that is remove the element which is present after k elements in the stack, where k is n upon 2 initially, right? So if we have some sort of this function remove after k, we can pass this stack and we can pass k equals n upon 2, and that will solve our problem. Okay, so remove any element that is after k elements in the stack, that is this function will do. Now we see some sub problem pattern here, that is how I can implement this is step 1, I will remove and keep the top element of the stack, then what I will do is I will call the similar function remove after k with k minus 1, because I have removed the top element. Now there are k minus 1 elements left which needs to be removed, and then we will come to the middle element which we have to remove, right? Now our step 3 would be, now what this remove after k will do, this will actually return us with the stack with that middle element removed, the element which is after k minus 1, that is removed, and now we are back with this stack, and all we have to do is just put that top element back to the stack. So put back the element from step 1 on top of the stack. Okay, let me explain what I am trying to say. Okay, what I am saying is Let's say this is our stack. 1, 2, 3, 4, 5, right? And I want to remove the element that is after two elements. So when in the first call I will say k equals 2, what I will do is I will remove this element, store it somewhere. Now we are not using any data structure here because this is just one value, so it can be stored in somewhere like temp int temp equals 5, something like that, right? A simple variable. Now I will store it somewhere, and then I will call the same function to do this for k minus 1 element. Now I will call this remaining stack to with k equals 1, like remove the element which is after one element. So in this call this will store 4 somewhere, and now it will call the remaining stack with k equals 0, that remove the element after 0 elements. So 0 is our base case. Basically it means just remove the next element or just remove the top. We do not have to call again and again when k equals 0. So we will delete it, and this will be deleted, and then we will return. Now whoever called this will take this stack and put whatever it has taken out. So for example, in this case it took out the 4, so it will put the 4 back on the stack, and it will return back. Then this 5, so it will put back the 5 on the stack. So we are left with 1, 2, 4 and 5 on the stack. Make sense? So each call is only storing one element somewhere, so it will not require any data structure. However, if you see closely, we are actually utilizing the recursion stack here implicitly. That is, recursion will keep a call stack somewhere for us. So whenever we are calling, so initially like it will have something like with this stack k equals 2, then we have this stack with k equals 1. So somewhere it is actually utilizing some stack, but in our code we are actually not using some data structure explicitly. Okay, hope it's clear. Now let's go. So basically these are the 3 steps. So as we discussed, first we will define a function, something like remove after k, which will take a stack, and we will ask after how many elements do we have to remove the element. So after k elements we have to remove the element. Now we saw that the base case is 0, so if k equals 0, that is our base case, and in that case we have to simply remove the top element and we return. In other cases what we have to do is we have to store the top element somewhere. So that is our temp, that is our top, and now we have to remove it, and then we will make a recursion call. That is, we have to pass it on with k equals k minus 1, remove after k as comma k minus 1, right? And then so we will push the temp back. Okay, that is our remove after k function. And now let's call it for the original stack, remove after k stack, and after how many elements? N upon 2 elements that we have seen, right? Like whether it is n is odd or whether n is even, in both the cases we have to remove the element that comes after n upon 2 elements. N is the size of stack, so k becomes size of stack upon 2. Right? Let's run it. Works fine. Okay, let's also test edge cases. In interviews you would also require to show these skills, like that you are testing edge cases and all. That actually gives a good impression. So what would be a good test edge case here? So for like when n is odd, so a good test case would be when n is very small, that is n equals 1. So put a custom input where n is 1, and there will be only one element. Let's see if it works here. So yeah, in case of one element, that is removed. Now another edge case, when n is our even number. So for example, n is 2 and let's say these are the elements. Let's see if it works for n equals 2. It's working fine, it is removing 1, right? Okay, let's submit it. Works fine. And that's how we solve this problem. Thank you so much for watching. Feel free to ask any question or provide any feedback in the comment section. Have a nice day ahead.